Alright, well, let's welcome you to 1-2 functions. A lot of these functions you've seen in the future, in the future, more like the past. What we're going to do is just do a little quick review of some functions and maybe some new review, if that's possible. So let's think about some functions here. Well, many days you have phenomena that happen to you, and that phenomena is actually called math. If you've never heard of the song Phenomenon, like by LL Cool J, I'd recommend listening to it because it's pretty sweet. So a lot of times you have two quantities that are related somehow to each other. This is called a relation. So if we have a relation, that is when you have two items that are related to each other. Weird, I know. And then sometimes you have something that has an exact item in one set that's paired with exactly one item of a second set. This is called a function. So a lot of times you can have relations without functions, but you cannot have functions without relations. Huh, weird. So we're going to actually kind of skip example 1, but we're going to go to example 2 here. And here we're going to talk about independent and dependent variables, and we're going to make sure if any functions are actually, or we're going to, test our functions, see if they represent algebraically. Your independent variable is always your x value. So because you're always plugging an x in, and the result of x doesn't depend upon your y, the result of your y depends upon your x. So that is why y is your dependent variable. I usually remember my dependent variable before my x, because we never really plug in a y to solve for x. Here's one instance, but we won't talk about that today. Alright, so for example 2, if we want to determine whether the equation x squared plus y squared is equal to 8 represents y as a function of x, then what we want to do is we want to actually just solve this equation, and we're going to solve it in terms of y in terms of x. That means we're going to solve for y. So if we start with x squared plus y squared equals 8, and if we solve for y, well, we have to subtract your x squared to both sides. And then we get y squared is equal to 8 minus x squared. And in order to get your y by itself, well, we have to take the square root of both sides. So when we take the square root, now you have to remember, when taking the square root, you don't get just a square root of 8 minus x squared. You actually get a plus or minus. So if this is the case, what you actually have then is you don't have just one y value. You actually have two y values. You have where y is equal to a positive square root of 8 minus x squared, and then you have where y is equal to a negative 8 minus x squared. So if we're trying to determine whether this function represents y as a function of x, that is a no, because what happens is we have two values of x. The way you can kind of compare this is if you want to compare with something that make a little more sense. Let's compare with y equals, whoops, that's not y. Let's compare with y is equal to a plus or minus x. So what this would mean is if you would let x equal 2, then that means that y is equal to a positive 2 and y equals negative 2. And if you were to write those as an ordered pair, well, if you plug a 2 in for x, you get a 2 comma negative 2, and then you'd also have a 2 comma 2. And what we know about functions is you cannot have a repeated x value. If you have a repeated x value, then you cannot have a function. So we did all this work, and what happens is we actually got two different x values, but we have two different x values with the same y value. So I think it helps if you compare it to something that might make a little more sense in terms of numbers. So what happens is anytime you simplify solve an equation for y, and if you have two x values that serve a y, or if you get a y is equal to a plus or minus to something, this is a no. Alright, so here we're trying to figure out whether we can rewrite this function as y represented as x. That is a no-ski.